In this video, we're going to take a look at difference of squares factoring. Difference of squares factoring can be used whenever you have a perfect square minus a perfect square. So in this case, we have c squared minus 36. Well, c squared is equal to c times c, and 36 is equal to 6 times 6. So since we have that perfect square minus perfect square, our answer is c minus 6 times c plus 6. So how does that work? Well, imagine we were to distribute this back out. C times c would equal c squared. C times positive 6 would equal plus 6c. Negative 6 times c would be minus 6c. And negative 6 times positive 6 would be negative 36. Well, these two terms here would cancel each other out, and we would be simply left with c squared minus 36. So in other words, c squared minus 36 is c minus 6 times c plus 6, okay, as shown here. Well, let's continue to use that principle. What is 49b to the 4 minus 1 if we were to try and factor that? Well, 49b to the 4 is 7b squared times 7b squared, and 1 is 1 times 1. So we can say 7b squared minus 1, 7b squared plus 1, and that's our answer. And it works because we have a difference. How about if we had negative 11a to the 5th plus 176a? Well, we always try to common factor first. We see that we can common factor out negative 11 from both of the first two terms. And we see also that we can common factor out a from both of those two terms. So common factoring out negative 11a leaves us with a to the 4 minus 16. So we've got negative 11a times a to the 4 minus 16. So we've broken up this polynomial into two factors. Well, looking at a to the 4 minus 16, we see that we have a difference of squares opportunity. A to the 4 is a squared times a squared. 16 is 4 times 4. So we get negative 11a times a squared minus 4, a squared plus 4. But we're not done factoring until we're done factoring, so to speak. So this a squared minus 4 factor is another opportunity for difference of squares, because a squared is a times a, and 4 is 2 times 2. So a squared minus 4 is a minus 2 times a plus 2. So we have a factor of a negative 11a, a factor of a minus 2, a factor of a plus 2, and a factor of a squared plus 4. Moving on, 2m cubed n squared minus 50m. Well, we can factor out 2m from both terms, leaving us with m squared n squared minus 25. If we, now that we've common factored out the 2m, we realize that m squared n squared is equal to mn times mn. And 25 is equal to 5 times 5. And since we have a difference of these squares, we can use difference of squares factoring. So we still have the factor of 2m, but we also have mn minus 5 and mn plus 5. And finally, we get to this question here. Looks a little crazy. 16k squared m to the 4 minus 81z to the 18. Well, we see that our two coefficients are both perfect squares. The square root of 16 is 4 and the square root of 81 is 9. And all our exponents are even, so we can divide them by 2 as a way of figuring out what goes in the factors. So the square root of 16 is 4. K squared can become a k as the first factor in the difference of squares. M to the 4 becomes m squared, and we see that 4km squared times 4km squared is 16k squared m to the 4. Then 9z to the 9 times 9z to the 9. 9 times 9 is 81. 9 plus 9 is 18. And we see that we've got another difference of squares. 4km squared minus 9z to the 9. 4km squared plus 9z to the 9.